Now let us discuss about energy reservoirs, and before that let's define what is a thermal energy reservoir, or abbreviated as TER. Now a TER is defined as a large body of infinite heat capacity, alright. So a TER is a body or a large body of infinite heat capacity which is capable of absorbing or rejecting an unlimited quantity of heat without suffering appreciable changes in its temperature or thermodynamic coordinates. Now let us say this is a TER. Now this TER has infinite heat capacity. This means it can absorb infinite amounts of heat into itself, and it can also provide or supply or reject infinite amounts of heat, and in doing so there is no change in its temperature. It is almost equal to 0. And if you talk about the practicality conditions, that even if there are some changes that are occurring in this large body, those changes are so slow and so minute then that all the processes that are taking within this TER are termed or assumed to be quasi-static in nature. Okay, so that is why we say it is a body of infinite heat capacity that can continuously supply or reject unlimited quantity of heat. Alright, now let's pay attention to this diagram over here. In this figure we have two TERs. This is the first TER and this is the second TER. Now from this TER we have heat absorption. Okay, so heat is transferred, that is heat Q1 is transferred to the system through this TER. So the TER from which heat is absorbed or taken is called the source. Okay, and the other TER to which heat is being rejected is called the sink. So this is the second TER L. Now it's a common notion that heat travels from hot body to a cold body. So the TER from which the heat is being absorbed or from which the heat flows out is called the source, and it is assumed to be a hot body, and the body or the TER to which the heat is being rejected is called the sink and is assumed to be a low temperature body or a cold body. So we can say, so the temperature of TER H is greater than the temperature of TER L. So this is a common assumption that we need to remember. Alright. Now apart from this, that is source and sink. So you should always remember that the source has a higher temperature as compared to sink. Okay. And the source is the supplier of the energy or the heat energy, and sink is the place where we reject the heat energy. A typical source, you can assume that you can say that a typical source would be a constant temperature furnace. A constant temperature furnace, like a furnace which is firing a boiler, and a typical sink would be, let us say, a sea, to which the heat or the if you go back to the steam plant, the condenser is basically rejecting the heat to the seawater. Okay, so these are some examples of a source and a sink. Now in this given diagram, we are all actually seeing another term which is called MER. Now what is this MER? MER. Now MER is called the mechanical energy reservoir. Let me write it down. This is called a mechanical energy reservoir. Okay. And now what is a mechanical energy reservoir? Now this is a large body which is enclosed by an adiabatic impermeable wall, and it is capable of storing work as potential energy or kinetic energy. So this is a body. Let us define it in writing. So it's a body which is enclosed by an adiabatic. Adiabatic means no heat transfer to and from the system. Adiabatic impermeable wall. Impermeable wall capable of storing potential energy and kinetic energy. Okay. Now all the processes of interest within this MER or the mechanical energy reservoir are essentially quasi-static. So all the processes are quasi-static within this MER. So this is a point worth noting. So what does this MER do? This MER basically receives and delivers mechanical energy quasi-statically. So this is the function of this MER. Let me write it down as well. It receives or delivers mechanical energy quasi-statically. Alright, so this is the function of the MER. Now some typical example of an MER is, so if you are having an MER which is storing a potential energy, then it would be a wound spring. So when you wind a spring, okay, it stores the potential energy, and if you enclose it in an adiabatic impermeable case, it is called an MER. The example for an MER storing kinetic energy is the rotating flywheel. So you have a rotating flywheel. Alright, so these are two examples of an MER. Now this diagram which is drawn on the screen, it shows a cyclic heat engine, that is CHE, exchanging heat with a source and a sink and delivering net work in a cycle to an MER. So whatever net work, that is the difference between the turbine output work and the pump input work, that is your WN, W net, and this W net is being stored in the MER. And when required, the work can be used as input work from this MER itself in case of a spring or in case of a flywheel. Okay, so this is a video on the concepts of energy reservoir, what's a source, what's a sink, and what is an MER. Now after this, let's go on to the Kelvin-Planck statement of second law.